Good morning and welcome to the Coding Rainbow. Ooh, I'm too loud. Sorry. Gotta get a mixing board, a theme song. That's happening soon. It's gonna happen soon. I've got some energy today, even though I think I've I hurt myself in my side, like a pain. So when I go like this, it kind of hurts. So hopefully it's gonna be okay. But I'm here this morning to talk to you, the listener, the viewer, about. The camera shuts off immediately. About programming and JavaScript and probability and math and musical theater. So I have this topic that I want to do. Which I think will encompass a whole bunch of things about HTML and CSS and JavaScript and math. So I'm gonna spend some time this morning doing a whole lesson, kind of also around this idea of what I think I'll call I don't know, this sounds very lofty, but like a dynamic essay, meaning you have a piece of text or a tutorial or some content that you're writing in a web page, but it can be dynamic, so as you change numbers, other things change and that sort of thing. So I want to build an example about entering a lottery and chances to win and that type of stuff. So before I do any of that, let me just see, there's some people watching, which is good. Please let me know, can you hear me okay? Is the audio clipping? Is there noise? Is there any problems? You know, do I look okay as white balance? Can you see this screen okay? This text is probably very small, but when I look at source code, it will be bigger. Is this font size okay? And when I come over here, can you read what is on the whiteboard okay? That's kind of important as well. So let me know those things in the chat. Say things like audio is okay, whiteboard is okay, code font size is okay. So just say those things, or if there's a problem, tell me what's a problem before I start really getting going. So let me come over here and check. I think I'm streaming here on both audio is good, video is good. I've got a couple people on Twitch and supposedly 10 people on YouTube. All okay. That's good. Thank you. Okay. Oops. Now I'm over here. Okay. So that's a good sign. I'm going to get myself set up here and figure out exactly what I'm going to talk about. Okay. So let me set this up for a bit. This is so every day, and I guess at some point I should. I'm going to hit record and make this a lesson, but right now I'm going to just sort of informally talk about this. So every day, I wake up and I go to hamiltonlottery.broadwaydirect.com/show-hamilton. And I go down here and I find, okay, enter now, 2 tickets for $10. If you're not familiar with the show Hamilton, I encourage you to look it up. It's wonderful. I'm a huge musical theater fan. I would really love to go win this lottery. Oops, I'm putting in my birthday. Now you can all see that. I'm entering this lottery. And I enter it. My lottery entry has been received. So at 4 p.m. today, I will find out if I win 2 tickets to the Hamilton Lottery. I've probably done this, I don't know how many times I've done this. It's maybe I started doing this a month and a half ago. I don't remember when the online lottery started. And I've been trying to sort of figure out, realistically, I understand how probability works, and I understand about what my chances probably are winning, but let's say I do this over a year, how likely it is that I would win at least once if I do this 360 times, 1,000 times, 2,000 times. Also, the sheer disappointment of doing this every day and losing over and over again has led me to be interested in making a little project, and I started mucking around with this last night, which sort of looks at kind of some of the math behind entering a lottery, what's the probability of winning based on how many times you enter, what's the chance you would win, and then a little bit of a program that just starts simulating entering it and waiting to win one of those times. And so that's what I want to do, is I want to do a lesson about how this probability stuff works. Event probability, we're going to need this function in mathematics called logarithm to solve some of this. And then also how to build a web page that then simulates it and maybe add some features to it. So that is my plan. Is that a terrible idea? But meanwhile, aside, and I'm going to do that. I don't know why. Meanwhile, what I really should be doing was picking up and finishing off, and I'm just going to bring this up now, Where's my notes? So I was doing a set of video tutorials about pixels, and the only things I hadn't gotten to were making a quick like slit scan, which is a kind of classic image processing, video warping algorithm type thing. Showing how to do a slit scan to P5.js, and I was also maybe going to look at seriously.js. So it's 10 a.m. I have something I have to do at 11:45 a.m. So I plan to be here for 1 hour and 35 minutes, and then it's possible I would come back later in the afternoon if I have time. So I want to do this probability logarithm lottery simulator example first. Maybe I'll take a short break, and then I'll try to come back to the slit scan and seriously.js thing. So I'm going to take a minute to get myself a cup of water, get a little more set up in here. If you have any comments or thoughts or questions, please ask them in the chat on YouTube or Twitch, and I will answer them before I get going. Okay, I don't see anything in the chat just yet, but I'll be right back. I'm going to get some water. I realize you can hear me this whole time, like pouring the water. I forgot the live mic shouldn't admit. I don't know, never mind. I was going to make some joke about the TV show The Jinx. Okay, I'm back. This is the camera. I always look over here because this is my preview screen, and it's terrible because I'm half the time in the video I'm standing like this. But I would like to talk to you, the viewer, the person out there on the internet who I feel strangely connected to in a weird sort of way, but not a creepy way. A nice, thoughtful rainbow and unicorns, happy hearts and hugs kind of way. That sounded weird. Okay. So I'm looking in the chat just to see if there's anything. Thursday morning has always been such a good time to get people watching, and for some reason it only says 11 people in YouTube, which I've, gotten, I don't know, which is fine. You 11 people are wonderful people. Okay, let me just come over here. I'm just sort of practicing. Okay, I got this. The water's over there. I'm gonna move the water. Okay, let me get set up. Here. Okay. And this looks good. Oops, I'm not here. Okay. Let me close this. Boy, this is I probably should really plan this better, but I'm just gonna improvise this, as I always do. And who knows whether it'll be useful or simple. And I'm gonna get going now and start. Okay, I'm gonna hit record. So I'm gonna try to do, this is probably gonna be kind of long. I probably should break it up into a couple videos, but whatever. I'm just gonna get started and see what happens. And I'm going to build a Hamilton lottery simulator and talk about probability. Oh boy, you know what? Let me figure something out in advance. Before I do this, I want to work this out because I'm going to make some mistakes. So let's think about this. I'm going to practice something for a second. So let's say you flip a coin. You have a 1 out of 2 chance of getting heads. This is kind of typical classic probability. I'm going to be doing this twice, by the way, because this is probably going to be in the video. Now, let's say what I want to do is I'm going to flip a coin 3 times. And I want to know what's the likelihood of getting heads at least one of those times. That's sort of hard to figure out, right? Okay, well so there's a sort of weird problem here. Well, what's the, so I should do something that's 1 out of 3 times maybe? No, let's keep going with this. Okay. So there's 3 times. I want to get heads at least one of those times. Well, let me ask a different question. which is a similar question. What's the chance of me not getting heads any of those times? Well, there's a 1 in 1/2 chance of getting tails, a 1/2 chance of getting tails, and a 1/2 chance of getting tails. This is a little bit of not the best example because of the 1/2, but it's fine. We keep going with this. Now, the chance of getting tails 3 times in a row is all of these multiplied by each other, which is 2 times 2 is 4, times 2 is 8. So there is only a 1 out of 8 chance of getting tails 3 times in a row, which means the chance of me getting heads at least one of those times is 7 out of 8. So this is what I'm going to apply to a lottery. Let's say a lottery has only a 1 in 1,000 chance of winning. So if I were to do that 3 times, the chance of me not winning all 3 of those times would be 999 divided by 1,000 times 3. Another way of writing this is 999 times 1,000 to the 3rd power. So what is this value? I don't have a calculator in front of me, but we can use the magical internet. And I can say 999 divided by 1,000 to the 3rd power. You can see here that this still gives me a 99.7 chance of losing the lottery every single one of those times. Let's say I play that lottery 300 times. I guess I have to hit enter. I now have a 75, so if I play this lottery that has a 1 in 1,000 chance of winning, and I do it 300 times, this means I have a 25% chance of winning at least one of those times. So this is where I'm going with the Hamilton lottery. Let's say I have a 1 in 5,000 chance, which means I have a 4,999 out of 5,000 chance of not winning, and I play it 23,000 times. So I enter the Hamilton lottery, the ticket lottery, 23,000 times. You can see now I have a 1% chance of losing all 23,000 times, which means if I do it 23,000 times, I have a 99% chance of getting the tickets at least once. So if Hamilton runs for 23,000 shows and I can play the lottery every single one of those times, I will get tickets to go see Hamilton. Now, mind you, I already have seen Hamilton because I bought tickets a long time ago when saw it. But I just would like to go again or give them to... Anyway, this is not the point. I'm not trying to get... I'm doing some math here. I don't know if anyone's... How many viewers am I losing now? So I want to solve, but I need to, I'm just doing the math here. How do we actually solve this? So the question is, let's say what I want is so if that lottery, let's say the lottery has is a 1 in 100 chance. So there's a 99 out of 100 chance that I won't win. How many times to the nth power to have a 50% chance of winning? How do you solve an equation? I want to solve for n. How many times do I have to play to have a 50% chance of winning at least once? Well, if you ever have looked into the math behind how to solve exponential equation, you need the logarithm function. Okay, so that's my setup. I'm practicing. I should have hit record probably. So I think what I'm going to do, I need to make 3 videos. I'm going to make 3 videos. One is just this probability idea and how to write the code for. 1 is the probability idea, 2 is the logarithm problem, and 3 is the putting it all together in JavaScript. I'm trying to decide how to sequence these. Oh, whoops, sorry. Thank you. I forget about the button a lot. I'm glad Kurt in the chat mentioned. So this is my idea here. Okay. Probability. I'm over here again. All right. Oh, let me keep going with this because I gotta work out. So let's say I'm saying 2, let's say I'm saying 2 to the x power equals 64. Is that something? Right? What is that? 2 squared is 4. To the third power is 8. To the fourth power is 16. To the fifth power is 32. And to the sixth power is 64. So we know that x equals 6. But how do you actually solve for x? Like, what if I said 2 to the x equals 65? How would I solve for x? So there's a mathematical function called log. You guys can just turn this off and go do something else if you want, which is the inverse of exponents. So what is this saying? This is saying log of base 2 of 65 equals x. Is that right? 2 to the what power equals 65? I think that's right. Somebody in the chat tell me if I'm right or wrong. So the thing about this is, if I go to a calculator, you won't see a log base 2 button. You'll just see the log base 10 and the natural log. And in fact, if I go to like P5JS and search for log, the function that I'm going to use is just doing the base 10 logarithm. So I need to solve this problem with a base 10 logarithm. So how do I do that? Well, there is actually a formula. I don't know if it's worth trying to derive this, which I believe if I say log base 10 of 64 divided by log base 10 of 2 gives me the same answer. You could also approach this another way by saying log, so that's one way. Let me approach this another way. I'm figuring this out. I'm going to make a video lesson that explains it again, hopefully better. If I have this equation and I take the log of both sides, this is the equivalent of x times log of base 2, which log of 64, and then x equals log of 64 divided by log base 2. Aha! So that follows that here, n equals log of 0.5 divided by log of 0.99. So this would be the number of times you have to play a lottery, which you have a 1 in 100 chance of winning. To have a 50% chance of winning at least one of those times is log of 0.5 divided by log of 0.99. I'm pretty sure all of this is right. Let me go use the calculator to check. People are saying right in the chat. I don't know if I'm gaining viewers or losing viewers. I'm going to record a whole lesson to, in a second, I'm going to do this again. So if I say, so first let me check this one. So I want to just check, we know the answer to this should be 6, right? So if 2 to the x power equals 64, I have the number 65 and 64, we know that the number here should be 6. So if this is right, then my math is right. So if I say log of 64, oops, oh, that didn't work. I don't know how to use this calculator here. Log of 64 divided by log of 2 equals 6. Excellent. So now if I were to say, if I clear this, and if I say log of 0.5 divided by log of 0.99, I need to play a lottery that I have a chance of 1 in 100 of winning. I need to play it 68.9 times, 69 times rounding up, in order to have a 50% chance of winning. So what if I want to have a 99% chance of winning? Can you do like an edit thing here? No. Just want to like go back, It's an interesting calculator. Whatever. You get the idea. So I think I have this all worked out. The thing that I sort of skipped over, which I wonder if it needs more explanation, is how you go from here to there. I'm sure I could work this out, but it seems a little bit beyond the scope of what I'm doing. Right, because this is 2 to the x equals 64. So this means 10 to the x equals 64, 10 to the x equals 2. So if we take, which is the same, this value of x divided by this value of x, that makes sense. Anyway, I'm going to just leave that out. That's the law of logarithms. Is that the law of logarithms? The law of exponents? What's the law of exponents? That's like a term that I remember from some math class. Law of exponents. Look at this. It has to do with that. Look at that. It must have to do with this, right? Because 10 to the x divided by 10 to the x is the same as 1 to the x equals 6. I don't know. Yeah, 1 to the x divided by, oh yeah, I could derive that now. That totally makes sense. It's a lot to, yeah, I mean, while I'm here, let me just go through that thought, because I would like to figure this out. Okay, so I want to understand how these two things are equivalent. So for my own personal sanity, so boy, I haven't done anything like this in so long. So what the thing that I'm looking at is saying that right, I have 10 to the x equals 64. 10 to the x equals 2. Could I say this? Right, that's the law of exponents. That's this law of exponents, right? So I could take those two equations and divide them by each other. And then that's the equivalent of, that's the equivalent of saying 10 divided by 10 to the x equals 64 divided by 2, which is like saying 2 times 1 to the x. No, this doesn't make any sense. It doesn't work. How do I derive this? Okay. Somebody help me. Use Wolfram. Yeah. What did I miss here? Looking at this. Is that not legitimate to do what I just did? 1 to the x. Yeah, that doesn't work. I can't just divide those two equations by each other. That seemed like a lovely idea. All right, I'll work on this part. I'll work on this part later. Watch some more Khan Academy videos. It's beyond the scope of what I'm trying to do right now, so I went off the beaten path. I will come back to that. Somebody in the chat, I'm sure, just sees the error of my ways. But I'm definitely I'm just gonna look into that later. But I don't want to. It's already 10:25, so I want to get to some code. Okay, so. So I'm going to zoom back out here. I don't need this. I'm going to this. This is going to be good. This is the lottery page. This is where I'm going to start building some code. And I'm going to just check the chat. And OK, so I'm going to go and do this again. I'm going to make a video about event probability and the lottery. I'm going to make a video about the logarithm and how that affects event probability. And I'm going to make a video and I'm going to be like doing JavaScript and stuff all during this. Okay. I'm losing viewers, I can tell. Okay, here we go. I'm going to hit record. Hello. Hello. The other thing, by the way, I realized is I hit record and I walk over here saying hello, and what would be better, because I can trim videos rather easily, should hit record, stand over here, pause for a second, and then begin. So I'm going to do that. Welcome. Actually, I could just... Hello. In this video, I'm going to talk about probability, the math function logarithm, and do some JavaScript HTML stuff to simulate the Hamilton lottery. So really the larger topic here is lotteries. What does that have to do with probability? And how can I make a web page that sort of simulates entering a lottery many, many times to kind of predict and understand what's the chances of really winning that particular lottery over time. And if you don't know, Hamilton is a wonderful Broadway musical. You can enter a lottery every day where 21 front row tickets will be sold to the winners at $10 each. I enter it every day. I have not won yet, but I'm going to make a little example here that allows you to simulate entering it thousands of times so that everybody can win the Hamilton lottery. Okay, so let's first think about this probability question we have. So let's be a little bit simpler about this and just say there are 20 front row tickets. So let me come over here and say there are 20 tickets, which are 10 pairs. So when you enter the lottery, you can enter the lottery for 2 tickets. So let's say there are 10 winners. Now, the other question we have to know is like how many people are entering this particular lottery? I don't know the answer to that. I'm going to estimate based on my sense of the world in New York City. I'm going to estimate it at 50,000. I don't know if that's maybe way off, but let's estimate that there are 50,000 entrants. So the lottery has, this has a little bit of glare up here, but hopefully you can see that. 10 winners, 50,000 entrants. Now you probably know that if I have a coin, look, I have a prop. If I have a coin, this is so exciting, I have a prop. If I have a coin and I flip the coin, there's a 1 out of 2 chance of it being heads, right? Because there are 2 possible outcomes. One is heads, one of tails, meaning there's a 1 out of 2 or 50% chance of winning that lottery. So if there are 10 winners out of 50,000, 10 winners out of 50,000, this means there is a 1 out of 5,000 chance of winning this particular lottery. So what I want to do now is switch to write some code to simulate this probability, let the lottery run over and over again and see if we will eventually win. I'm going to get back to a lot more about this in a minute. Okay, so I'm over here. I have this page already set up, which it has a H1 element on it, Hamilton Lottery Simulator, and a paragraph that says, this simulator assumes 10 pairs of tickets available each night with 50,000 people entering each lottery. So I'm going to go to my code, and I'm going to do a combination of HTML, JavaScript, and some CSS to kind of build this, what I might call a dynamic essay for you to read about probability, change numbers in it, have other things adjust, and run the lottery over and over again. So one, let's just make the statement. This, you have a 1 in 5,000 chance of winning the lottery. So one thing I want to do, by the way, okay, so one thing I want to do, let me show you something here. What if I so I have some code, it's completely empty. And one thing I want to do is I want to allow people to edit that number. I want that number to be able to change, and when that number changes, I want this to change also. So let's work on that. So one thing, in order to do that, if I want to make something editable, I first need to make it its own DOM element. Right now the number 10 is just inside this paragraph. So I want to say span, and I'm going to give it an ID. ID equals winners, and I'm going to put span behind it. So now you can see nothing has changed on the page. It's still the number 10 here, but look, HTML DOM elements can have things called attributes. And one of the attributes you can have is called content. Oh, I'm zoomed out. No wonder you can't see. Editable. So I'm just putting in the HTML tag the word content editable, which means it has that attribute. Now look over here. I can say 99, 1,000. 2,000, right? I can now edit it on the page. Notice I can't edit anything else, only this particular number here, because only that particular span is content editable. So now if I go into my code, and I make a variable called winner span, and I say winner span equals select winners, I think that's what I called it. Let's go back and look. winners is the ID. So this function select is a P5 DOM selection function. Now there's lots of ways to do these kind of grab a DOM element from the web page. This is in P5 select. The hash symbol means select by ID. And so now in here, I can actually always look at that content. For example, if in draw I say console.log winnerspan.html, and I go back here and refresh this page, you can see what's printing out in the console, 10, over and over and over 10. And here, if I change this to 20, now I'm getting 20. So what if what I want is when I change the number 20, this should also change. This should now say you have a 2 in 5,000, or a 1 in what? So if I want a 1 in what, camera, what do I need to do? I need to do some math. I need to take 50,000 divided by the number of pairs of tickets, right? With 10 pairs of tickets, 50,000 divided by 10 is 5,000. So this number, the 5,000, is the number that's going to change. So I also now need to go to my HTML file and make this, and I'll call this chances. So I could make that editable too, and then if you change that, it changes the number of winners. But let's keep things simple and only now edit and update this. So what I'm going to do now is go back to my JavaScript file, and I'm going to say chances span, and I'm going to select that. I think, did I call it chances? Yes. And so now, what I'm going to do is in draw, I'm going to say odds equals chancesspan.html divided by winnerspan.html. Wait, no. What am I doing? 50,000 divided by the number of winners. So this is actually just a number. 50,000 divided by that. And then if I say chancesspan.html odds, now what will happen? It will update that DOM element with the content. So let's go back. This looks right? It's actually already doing it. 50,000 divided by 10. Let's change this to 20. Whoops. 2,500, 30, 50, 50, a 1 in 1,000 chance. So this is working. But it was getting some weird numbers. So one thing I'm going to add here is floor, so that it always is an integer whole number. Let me refresh it. And you can see that whenever I change it. Now, if I put 0, it's going to say things like infinity. And if I type some random text in there, it's going to say not a number. So I should probably, at some point, do better error checking. But for right now, we can see here, back to 10. If there are 10 pairs, you have a 1 in 5,000 chance of winning the lottery. I should also probably do some formatting to add a comma in there, but I'll worry about that another time. OK, so what's happening now? We are starting this dynamic page about probability. Let's now actually run the lottery based on this particular probability. Pause. I'm sorry, my brain just I didn't mean to go so far into HTML DOM elements in this particular opening video, which was just going to be about probability stuff. Yes, Kurt asks in the chat, or I don't know if he's asking or just telling somebody, oh, can you please do a JS scraping tutorial? I will do that. Okay, sorry, I don't know if this is a good idea or not. But I want to keep building out this example, and I probably should just go and do the slit scan thing, and maybe I'll come back to this another time. Because I think I now have, I went too far into the DOM thing, I'm thinking. Give me a second, I'm going to drink some water. Yeah, okay. I'm going to, ooh, did I plug in my phone with the low battery? Hold on, I'm just got to check something. looks like, yes, it's charging. Okay, 10:35. I still have an hour. I'm maybe going to try doing this again and not going so far down the DOM road. Trying to think of where can I go back and edit together. People are having all sorts of great suggestions in the chat about other things. Okay. I'm sorry, I'm thinking. I think probably what I should have done is only done the math in one video and then written the code in another video. And I need to have a better sense of what I'm doing. I don't think I needed to do that content editable thing just yet. So what if I go back? I'm going to look at what I just shot for a second because I might actually edit together. I'm going to look at what I just shot. I don't like to edit, but I don't want to go all the way back to the beginning either. I'm going to find a point where I could maybe, you guys can't see what I'm doing, but I'm looking at what I just shot. And I'm going to look through it. And I'm going to find the point where I went. I don't have any audio from this computer, which is the problem. Sketch your way out of this. I'm going to find the point where I went to the code. I wish I could hear what I'm saying because I know what I could edit together. It's at 2 minutes and 47 seconds. So then I went 5 minutes in, too far down the, so let's see. So that would be a good place to go back to. 1 and 5, so, okay. I think I can make this. I think I can make this work. Oops, sorry. Okay, everybody. Okay, yeah, I have a better idea now. Sorry, everybody. Okay. Yes, yeah, that's a very good point, Kurt Strong, who mentions about reminding people to include the DOM library. I will, I'm not going to do that part right now, so I'll remember to tell people that. So I'm actually going to take this out. Come back to it later. I'm going to go back to index.html, and I'm going to take this out, and we'll come back to this DOM aspect of this later. Okay, so I'm going to splice stuff together from when I was going from here over to the computer. And so I can actually just put this here, and then here we go. So I'm going to hit record, and I'm going to come over here, and I'm going to do some sort of, I don't like to edit. You can't see me right now. What I'm going to do is I'm going to walk into here as if I had just finished drawing on the whiteboard. I wish I could remember what I said, but it'll be fine. Okay, the microphone's still on me. Let me just check. I want to check my battery levels. 1 bar, 2 bars. I think I'm okay for a little bit longer. I probably need to replace the batteries. Okay. All right, here we go. Coming over here, over here, I have a web page set up You can see it right here, that just says Hamilton Lottery Simulator. And this is what, over the course of these tutorials, I'm going to build. A simulator that allows you to run the lottery over and over again, tweak values, and understand about how probability works. So this simulator assumes 10 pairs of tickets available each night with 50,000 people entering each lottery. And now, what I'll just do is add another sentence. You have a 1 in 5,000 chance of winning the lottery. And I'm editing this HTML file. I also have a JavaScript file where I'll add the code stuff to make things happen dynamically as well. So if I hit refresh, and we now say you have a 1 in 5,000 chance of winning the lottery. So here's something else I want to understand about how probability works. So I know that if I enter once, I have a 1 in 5,000 chance of winning the lottery. But if I enter twice, what's the probability of winning the lottery at least one of those times? Now you might think it's 2 out of 5,000, which would be correct. Hold on, pause. But if you enter 5,000 times, that's not correct. If you enter twice, 2 entries, 2 entries does not give you, right? 2 entries in the same lottery gives you 2 out of 5,000 chance, because only one of, but not if you enter in 2 days in a row, because you only have a 1 out of 5,000 chance and a 1 out of 5,000 chance, which is different than like okay, I have to say this. This stuff is confusing. I'm almost like, I don't think I've ever sworn on any of my videos, but I was about to swear. Okay, yeah. Right, okay, think about this. I stopped recording for a second. Think about this, right? If you flip a coin 2 times, you don't have a 2 out of 2 chance of getting heads either of those times. You have a 1 out of 2 chance twice. So I'm gonna come back to this, and I have to do this part again, which is kind of ridiculous, but I'm going to. I've really lost my mind with this idea. Coming back to the computer, I'm going to show you what I'm setting up for this set of tutorials, which is a web page where I'm going to write information about probability and odds, and then also have things happen dynamically, like the lottery run, or you change numbers and probabilities change, that sort of thing. So the pieces of this are an HTML file which holds this content, and a JavaScript file where all the math and code and logic of the probability will play out. So let me briefly just look at the HTML file, and I'm going to add a sentence that says you have a 1 in 5,000 chance of winning. And then I'm going to hit refresh this page, and you can see you have a 1 in 5,000 chance of winning. So let me ask the question now. This is the sort of key question. How many times would you have to play that lottery to really guarantee that you're going to win at least one of those times, right? What if you play the lottery twice? You do it today and tomorrow. What are your chances of winning at least one of those times? Now, you might think that the answer to that is you have a 2 in 5,000 chance of winning one of those times. But this is actually not the case. So let's do some more probability math. This is really exciting stuff, and it's not really, or if it is or it isn't, but whatever, you can just turn this off if you're like, go away crazy person about probability. Okay, let's think about this. So remember flipping a coin? I think I was here before. You have a 1 out of 2 chance of getting 50%. What if you flip, a 1 out of 2 chance of getting heads. What if you flip that coin twice? What if you flip that coin twice? You don't have a 2 out of 2 chance of getting heads at least one of those times. You could easily flip the coin twice and have it be tails both times, right? But you do know that you have a 1 out of 2 times a 1 out of 2 chance of getting tails 2 times in a row, which means you have a 1 out of 4 chance of getting tails twice in a row. If you have a 1 out of 4 chance of getting tails twice in a row, that means you have a 3 out of 4 chance of not getting tails twice in a row. And what's the equivalent of not getting tails twice in a row? It's getting heads at least one of those times. So the way the probability works of thinking of if I'm going to enter this lottery 2 times, right? The chance of me not winning the lottery is 4,999 out of 5,000. The chance of me not winning the lottery again is 4,999 out of 5,000. So the chance of me not winning the lottery twice in a row is this times this. And in fact, what is the chance? Camera, come back. So let's go play that math out a little bit more here. And I'm going to come back. I'm going to come back to the browser, and I'm just going to use the calculator. So if I say 4,099, I was doing this math earlier apparently, right? If I do this math now in the browser, and I'm going to get a nice little like Google calculator probably, you can see that this is still my chance of not winning the lottery, meaning my chance of winning the lottery is not that much better than doing it once. But another way of writing this, another way of writing this is to the second power. So you can see this is the chance of me not winning the lottery both times I play it. But what if I play it 200 times? The chance of me not winning the lottery 200 times in a row is 96%. This means if I play the lottery 200 times, I have a 4% chance of winning at least once. Not so great, 200 times. I don't know how many shows Hamilton does in a year, but what if I were to play it 2,000 times? Now I have a 2/3 chance of not winning all those times, meaning a 1/3 chance of winning. And if I play it about 25, maybe 5,000 times? No, I was trying to get, what's the 2,500? I feel like I did this math earlier. 3,000? I want to get to around 50%. Okay, well, that's about 50%. You can see if I play the lottery 3,000 times, what we're learning is you're not going to win that often. But get the idea of this probability here. This is how you work this out. Now we have another problem though. Let's say I actually just want to, let's say I actually just want to do some math. I'm just typing in numbers to try to figure out the probability. But what if I actually want to solve this as a formula? So what I'm saying is, erase all this. I have a 1 in 5,000 chance of winning the lottery, meaning I have a 4,999 chance out of 5,000 of not winning the lottery. How many times do I have to play to the nth power to have, let's say, a 0.01, a 1% chance of not winning the lottery all of those times? So what I'm trying to solve for is how many times would I have to play the Hamilton lottery to have a 99% chance of winning the lottery at least one of those times? And I need to solve for n. Now's where some more math comes in. How do you solve an exponential equation? Something like 2 to the n equals 64, right? How do you solve an equation like this, which is kind of the equivalent thing? Now, looking at this, I can see, because I know, and I thought of this earlier this morning, that 2 to the 6th power equals 64. So, but this isn't, there's no way I can just, in my head, sort of visualize the answer to this equation. I need to figure out a way of solving for it and maybe ultimately using the calculator or some code to solve for it. So how do we do that? Well, the way to do that is with a mathematical function called logarithm. So logarithm is the inverse of exponents, meaning log base 2 of 64 equals 6. 2 to the 6th power equals 64. So in that sense, if this is the thing I'm trying to solve, if this is the thing I'm trying to solve for, then the answer equals log base this of 64. So the question here is log, right? Log base 499 divided by 5,000 of 0.01 equals n. So this is what I need to do. I need to calculate log base 4,999 divided by 5,000 of 0.01. That's the number of times I need to play the lottery to have a 1% chance of not winning all those times, meaning a 99% chance of winning at least once. So let's go back to this calculator over here, and we'll see that log. There is a log, and there's also this ln, which is natural log. Okay, and if I go to I already have this page loaded. If I go to the P5JS reference, there is a log function in JavaScript, so I could use this to make this calculation in my code. The problem is the calculator and the JavaScript function only assume log base 10. So how do I solve this? Well, it turns out, and this has to do with the law of exponents and how logarithms work, and I'm going to kind of skip over deriving this, but maybe if people are interested, write in the comments and I'll make a separate video that goes through just this part. I can actually say the equivalent here, the equivalent of this, right, n equals log base 2 of 64. I can also say n equals log base 10 of 64 divided by log base 2 of 64. So these are actually the equivalent. So what I can do here is say n equals log, I got turned around here for a second, log base 10, this is, sorry, this is wrong. Log base 10 of 2. Log base 10 of 64 here, meaning 0.01, divided by log base 10 of 4,999 divided by 5,000. You guys having a headache right now, right? So this is actually the way that I can solve for this particular probability problem. So let's come over here. Oops, where am I over here? And let's go back to the calculator. And I'm going to say log of 0.01 divided by log of 4,999 divided by 5,000. And what does that equal? 23,023. So I need to play the lottery around 23,000 times to have a 99% chance of winning it at least once. So I'm going to go back to my code now, and I'm going to say, in order to have a 99% chance of winning the lottery at least one time, you must play approximately 23,000 times. Okay, so if I come back here, look at this page, we can see this is where I'm starting. So what I've done is that I have done now sort of like the theoretical math here, which is that saying there's 10 pairs of tickets, 50,000 people entering the lottery, one entry has a 1 in 5,000 chance of winning, and if you play around 23,000 times, you're going to have a 99% chance of winning at least once. So this concludes this particular video just discussing the math behind the Hamilton lottery itself. And what I'm going to do in the next video is add a lot of JavaScript code to simulate the lottery, allow users on this webpage to change the numbers around, and have the lottery continue to simulate based on new probabilities. And that will be in the next video. All right. Someone writes, events are independent when entering 2 days in a row. That's correct. And I should have probably said that more explicitly when I was talking about the coin flipping thing. I'm definitely not gaining viewers. But I'm going to get to the JavaScript stuff now and the HTML and CSS stuff. So let me just take a short mental minute here. And oops, I'm over here. and see what I can do here. So now I'm going to make this dynamic, add a button to play the lottery, and then estimate the amount of time, and also allow users to change the numbers, maybe with a slider, various things like that. Depth of field on whiteboard camera not as good as green screen side. Thanks for mentioning that. Is this all legible and in focus? And maybe it's just me who's out of focus? Probably because I focused on the whiteboard. Let me actually look real quick and see if I need to improve that. It's sort of too late now that I shot that whole video. Focus seems okay. The depth of field is a bit of a problem, I agree. All right. Okay, let's see here. I'm going to go to the JavaScript stuff now. I still have about 45 minutes before I have to go. So let's see. Okay. All right, so the next thing I'm going to do, I'm going to hit, let me cycle the cameras because those keep going on and off. I kind of want to just record that whole thing again because I could make it sort of cleaner, but I guess this is what I'm doing. Whiteboard good, you less. Yes, so I think it's because, you know why that is? It's because I keep standing up here, which is I'm pretty far. Like if I actually stood close to the whiteboard, I'd be more in focus. I missed the start. Both XP writes, I missed the start of the recording. Where did equals 0.01 come from? I assume you're. Oh, so that number is associated with me trying to determine that you have a 99% chance of winning the lottery at least once, which means a 1% chance of not winning the lottery ever. So that's where the 1% comes from. Okay. And now I'm going to keep going with this. Okay, in part 2 of this video series, I've gone through all of the math behind the Hamilton lottery okay. Start over. Now on to part 2 of these videos about the Hamilton lottery. So in part 1, I went through all the math behind a lottery that assumes 10 pairs of winning tickets out of 50,000, a 1 in 5,000 chance of winning one of those pairs. And if you enter that lottery 23,000 times, you're going to have a 99% chance of winning at least once. So I did all the math behind that. Now what I want to do is make a web page, simulate the lottery, doing it over and over again, and allow users to change to make 15 pairs of tickets available, 5 pairs of tickets available, and have all of the numbers change to reflect that. So let's go look at how we might do that. So first, let's just write some code to simulate the lottery with these numbers themselves. So if I go to my JavaScript code, I have an empty P5.js sketch. If you're not familiar with P5.js, I'll refer you to all my P5.js videos, but I have a setup function where things start and a draw function where things loop. So what I'm going to do is say, I'm in a variable called total, which equals 5,000. That means there is, maybe I should call that probability, like a 1 in 5,000 chance. You have a 1 in 5,000 chance of winning the lottery. So this is sort of a silly thing I can do, but I can say pick a random number between 0 and 5,000, or between, right? So pick a random number between 0 and 5,000. The highest number is actually 4,999, right? Because between 0 and 9, that's actually 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to also use the P5 or a JavaScript function floor, which will ensure that that number is a whole number, an integer number, right? So I'm only getting 12, 31. So if that number were to equal, I don't know, I'm just going to pick one. Let's say we're equal to 1. Right? If I happen to pick 1, I could have picked 0, I think. I could have picked 3. I could have picked 20. It doesn't matter. Then I've won the lottery. Won lottery. Otherwise, console.log lost lottery. So I could run this program, and you can see I'm losing the lottery over and over and over again. Over and over and over again. Now, remember, we had to play the lottery 23,000 times to have a 99% chance of winning at least once. So we might be here for a while before I actually win the lottery at least once. And I was sort of hoping it might happen by accident, but it's not happening right now. So let's just go adjust the code to be sure what we're doing makes sense. And by the way, this should be that variable. Did we win yet? No. So let's just make this a 50. I have a 1 in 50 chance of winning the lottery. We should win that fairly quickly if we're doing it over and over again. So let's make sure this actually works with 50. Yes. So you can see I'm winning the lottery a bunch of times. So I played 96 times and then I won, then 12 more times than I won, then 82 more times than I won, then 34 more. So you can see how this works. So one thing I want to do now is I want to have the web page, right? I want to have this web page have a button that you press the button and you start playing the lottery. And then I want to have a DOM element on the page tell me whether I've won or lost. So right now everything's just printing out to the console. So how do I do that? So the first thing I want to do, and there's a lot of different ways you could approach this problem with any number of JavaScript frameworks. I'm going to do it one particular way. So what I'm going to do is I'm going to go to the HTML file, and down here I'm going to add another paragraph, and I'm going to make a button element. And can you see this? I'm going to zoom in on it. Button, I'm going to give it an ID, and I'm going to call that ID start. So I'm making a button to appear on the page, and I'm going to make the text for that button start entering lottery, and I need to zoom out here. And then I'm going to say /button. So I add this to the web page, and I need to close the paragraph tag as well. Once I add that to the web page, you can see there it is. Their button now is there, start entering lottery. So I want some code to trigger when I press that button. How do I have code trigger when you press a button? In P5, using the P5.js framework. First of all, I have to have access to this DOM element. Somewhere in my code, there it is in the HTML file, and it has an ID called start. That ID is very important because that's the way I'm going to access that DOM element. And I should mention, you need to have for this code to work, you also need to have the p5.dom.js library included in what you're doing. So I'm going to add a variable called button. And in setup, I'm going to say button equals select start. So you can see button equals select start. So now I have got that button. And I'm going to say button.mousepressed start lottery, which means when you press the mouse, start the lottery. What's start lottery? It's a function that I'm going to write called start lottery. So maybe I'll do something. This is sort of a silly way to do it. I could do it any number of other ways. But I'm going to make a variable called started, and I'm going to have that equal to false. And in the draw loop, I'm going to say if started, do all this stuff. And let me just indent this because I am obsessed with indentation. And then in start lottery, I'm going to say started equals true. Now, all of you JavaScript programmers out there are probably going to complain to me all sorts of ways I'm doing this wrong. For example, this function could actually just be right inside of mousepressed as what's called an anonymous function. And the draw loop is maybe a silly thing to have here because there's no actual drawing animation. I could use something like set interval to actually start the process of playing the lottery over and over again. But for simplicity, I'm going to keep this model here for right now. So we can see that if I refresh the page, nothing is happening in the console. But now if I press start entering lottery, I'm playing the lottery, I'm winning, I'm losing, I'm winning, I'm losing, because I have a 1 in 50 chance of winning it, which is pretty good. And I'm going to see Hamilton tonight. Okay. But I want to do something else. Instead of just logging to the console, I now want the web page to tell me whether I've won or lost. And I'm sure I could come up with use Canvas to make some clever animation or have things flying around the screen. I leave that to you to be more creative with this. But what I'm going to do now is just say the Hamilton lottery, when you actually, I'm going to make a paragraph with an ID results. When you play the actual Hamilton library, this needs quotes around it. It just says try again. So what I'm going to do right now in my code is I'm going to get that DOM element using the select function. And then instead of saying won lottery or lost lottery, I will use the P5 HTML function to say try again, or you won. So you can see here, the idea here is that if I win, put inside that paragraph element the words you won. If I've lost, put the words try again. And I'm also going to add something. Once I've won, I kind of want to just stop the code from running at all. And in P5, I can say no loop, and the code stops. I mean, how are we doing here? 7.5 minutes in this video. I don't know if anyone's still watching. OK, so here we go. And now I'm going to start entering the lottery. It says try again, and then immediately says you won, and it stopped. Now let's go back and change it to 1 in 500. Start. I won pretty fast there. And you know what I'm going to do? I'm going to add the function loop in here. I'm actually going to say no loop here. So I'm going to have the program isn't going to be looping at the beginning. Anytime I hit start, it starts the loop over, and the lottery starts running. So here we go. Try again. Come on. I'm going to win. I want to win. I want to win. Come on, win. I won. Yay. Who's going with me to front row tickets to Hamilton? OK, so I momentally got distracted thinking I actually won something. It's very confusing here. So one thing that I think would be useful is for the page to sort of show me how many times I've played so far. So another thing I want to do is in this, here I'm going to add another paragraph, and I'm going to say you have played 0 times. So on the page, it says you have played 0 times, and when I press start entering lottery, I want that to start counting up, showing me how many times I've played. It's still 0. So how do I modify? I could just modify that whole paragraph, but what if I want to modify just one number inside an existing paragraph? So a way to do that is make this a span element. Span equals, span ID equals, I'll call this total. And if I go back to my code and I add a variable called total and have that equal to 0, and then every time I play the lottery, I increase total by 1, I could also say, and you know what? I'm going to show you something. I can say select total.html total. So one thing I can do in JavaScript is something called chaining. Do you see how here I said select results? And then put that in a variable and say .html. Well, I could sort of bypass that by just saying select total.html total. So update the total DOM element with the value in the total variable. And now I'm going to run this again. And here we go. So we kind of have a little bit of a dynamic page now where it's saying try again. It's telling me how many number of times I played. I have this button. I won after 459 times. If I press the button, oh, it's doing it again. So one thing I notice here that I might like to do is in start lottery, I should reset total back equal to 0. And we can see this again. Here we go. Am I going to win? Am I going to win? But one thing I should remember is the probability here is 5,000. So I'm going to run this again. So this is the basic idea here of kind of making a dynamic page, a page that might have some information. Obviously, my design level here and what's the content here is very simplistic. I'm like waiting to win. And you might have some better and more interesting ideas. I'm going to actually stop this video now. I'm going to do one more. And the next video, I'm going to show you how to make this a bit more interesting by allowing some of these numbers to be editable by the user. So what if the user could come up here and change that number 10 to suddenly have 20 tickets become available, have all of these things update, to have the number of times you have to play to get a 99% chance to update, to have the 1 in 5,000 chance change? What if I could sort of use a slider to change these values? And then when you play the lottery, the new probabilities actually happen. I was really hoping that I would talk long enough that I would win before this particular video ends. I'm going to let this keep running, and in the next video you'll see hopefully the time that it took for me to win. Okay, Hello, chat. This is not, I don't know how this is going here. I'm still playing here. It should, once it gets to 23, I would think that we're going to win, I would have guessed that we have a pretty good shot at winning, around 10,000 or so. We'll let this keep going. I should have just made the slit scanning video today. Oh, that all made sense. Okay, thanks, Kurt. It's very hard to do this with no... for some reason, I felt like this morning trying like something different and kind of having like a strange topic with maybe making a project and kind of going through how to make that project and like touch on different topics like probability in it. And I'm not so sure how this is working, but put it out there, see how things go. And what I hope is that maybe some of you, I'll put all this on GitHub and actually make it like a website. And maybe some of you will want to do a pull request to like help me with styling and design and make this more of an interesting page with more content about how all this stuff actually works. And maybe I'll embed the YouTube videos in it. It'll be very exciting. Come on, let's win already. Yes, thank you, Kurt. That's exactly what I was kind of going for. So I really want to make sure this works. So before I record the next one, I'm going to wait to win. A lot of these ideas in what I'm sort of doing here are similar to some of the like Brett Victor. If you look up Brett Victor, makes a lot of these kind of dynamic essays, content with written and image content that's changeable. I put 5,000 in the code, right? Let me just check. 5,000. So let's say we've played 12,000 times. What was our chance of not winning all those times? 99%. So we should have 10%, 9%. We had a 90% chance of winning, and we just gotten unlucky. Or is something wrong in my code? But what could be wrong in my code, right? It worked when I did 500, worked when I did 50. I'm just getting unlucky here, I think. I have a no higher chance of winning right now than I did when I started. It's just, it's not like, it's just, I haven't gotten lucky yet. Boy, I'm really never going to see Hamilton, am I? I know you'll all be filled with suspense, I think at 4 p.m. Eastern time today. All right, I guess I'm going to let this keep running. And I'm going to adjust the code. Next. We won! 15,420 times. We played the lottery 15,420 times and won our tickets to Hamilton for $10. Okay. Now I can start the next video. Okay, yeah, we should be taking bets on this stuff. Okay, how's the battery life doing everywhere? This computer needs the plug. Let me just check the microphones. This has 1 bar. I think I'm going to keep going with that. This has 2 bars. Okay. Part 3 of the Hamilton Lottery Simulator. Here we go. Part 3 of the Hamilton Lottery Simulator. Here we go. So if you were kept in suspense in the previous video, I let it run, and after 15,420 times of playing the Hamilton Lottery, we finally won our 2 tickets at $10 each. See you tonight. I'm not at the show. Okay, not really actually, but okay, but now What do I want to do to this? I want to make this a bit more interesting. The goal here is to kind of make a little project that's about probability using JavaScript. And so what I want to do is I want to change something about this. I want to make it so that this number here, for example, I could edit. So how many tickets are available, or I could edit how many people are entering the lottery. Maybe let's change how many people are entering the lottery, because we know, I know based on the website that there actually are 10 pairs of tickets available. So that's sort of like a fixed number. But I don't actually know how many people are entering. So I'll leave it up to the user to estimate that. So one thing that I want to do, I could make a text input field, or I could add a slider here. There's lots of ways, but I'm going to do it kind of a strange way, which is I want to make this editable. And I want to show you, if you recall, this number is actually, this element, if I click inspect, you can see over here it's a span with an ID called total. That's what's in the HTML page. So if I want to have this number sort of exist as its own thing that I can manipulate and play with, I also want to make it a span. How do I get back to the console? I also want to make it a span. So I'm going to go back to my HTML file, and I'm going to go up here and I'm going to say span ID equals, I'm going to call this entrance, as in the total number of entrants. And later I'll maybe do something fancy to have like commas appear automatically or something like that. But right now I'm going to leave that at 50,000 with no comma. And I'm going to go back, and you can see that there it is, 50,000. One thing I want to do is I want to add a little bit of styling. So the way, right here I'm in the style tag in the header. I could have put this in a separate CSS file. I'm referring to the ID by entrance. And I'm just going to do something like, say, background color, make it like a light gray, just so we can see that that's a light gray. And then maybe I'll also add like a little padding around it. So you can just see that it looks like something different. Now, somebody is going to be once I post this to GitHub, some nice designer will come along and redo my CSS and fix it up to make it nice. But the whole point is I want to be able to edit that. So to be able to edit that, this is actually not something I'm going to do in the CSS. DOM elements on a web page have things called attributes. Attributes are ways of modifying the behavior of a particular DOM element, not associated necessarily with just its sort of design, its style, its look. And one attribute is called content editable. So actually, if I just write content editable here in the span as its own word, this is the equivalent of saying this. Content editable equals true. But I can just put the word content editable in there, which means it now has an attribute content editable. Ugh. And now you can see here, this is actually editable. So I can just change this to any number I want. So I'm going to go back to 50,000. So the point of this is what I want to do is now, if the user comes here and changes that number, I want everything else to change to reflect it. I want to have this say how many times you have to play to have a 99% chance. I want this to say you have a 1 in what. So in other words, as soon as I change this to 40,000, this should say you have a 1 in 4,000 chance of winning. So now we need to look at what are the DOM elements that need to be updated. So this number 5,000 needs to change, and that number 23,000 needs to change. So I need to make those also spans that I can access. So now I'm going to come down here, and I'm going to say span ID equals chance. And I'm going to come down here and say span ID equals 90. I'll call this one 99. Can I make an ID a number? I don't see why not. And let's call it 99%. The 99% of us who aren't going to see Hamilton, because the tickets are very expensive. I don't even know if you can get them. OK, so now I have those elements as spans. Now, I have a question. How do I know when the user has changed the number 50,000? Now, one thing that I could do is draw is looping over and over again. So there's this draw loop looping over and over again. So I could always just say like, always check the DOM element, update the number, check the DOM element, update the number. But that's not very efficient. And in fact, I actually turned off the draw loop unless the lottery is running. So it isn't really looping all the time. What I want to do here is I want to say only when the user changes a value in that field do the other numbers update. So I need an event. Just like I have an event for when the user presses the button, I could now have an event for when the number in this content editable span changes. And let's look at how I could do that. So first thing is, if I go back to the HTML file, I need to remember that this thing that people are changing is called entrance. So let me go back to the sketch, and I'm going to say entrance equal entrance, and in setup I'm going to say entrance equals select entrance. Okay, and now I need to make an event. Entrance dot changed update probability. So just like, look at these two areas. Here's the button. When the button is pressed, call the start lottery function. When the entrants have changed, call the update probability. Probability. So this means I need to write a function called update. Whoops, called update probability. And let's zoom back out and scroll down a little bit. So I need to write this function. So what do I need to do? The first thing I need to do is calculate what is the new probability. I have a 1 in 5,000 chance because I have 50,000 entrants divided by 10 pairs of tickets. So the new probability, 1 in 5,000, is 50,000 divided by entrance.html. So the HTML function in a DOM element allows you to set the contents of that DOM element, but it also allows you to retrieve it. We can check this, right? This, if I type entrance here, we can see that's a P5 element. Can you see that? Let me give myself some more space here. If I say entrance.html, you can see it has the number 50,000 in it. If I change that to 40,000 and say that again, it has the number 40,000 in it. So what I want is, I want to, when the probability is updated, change that number, probability 50,000 divided by entrance, and then I need to update. What do I need to update? I need to update this number, the chance. So here I want to say var chance equals select. Actually, I'm just going to say select chance.html prob. So let's look at this. Now I'm calculating that new probability, and I'm updating that DOM element. So let me go back and change this. Ooh, what happened there? What did I miss? So I don't know what I missed. So I don't see it working, so I have to debug this somehow. So first let me just call that function. Okay, it worked. 1 in 1.25 chance. So something happened. So first of all, my event didn't work. Because clearly that function does something, but my event didn't work. But also the math in that function is wrong. So let me go back and try to fix that. 50,000. Oh no, I'm being so silly. The entrance is the number for, well, you guys probably figured this out like a while ago. Entrance is the new number that's replacing 50,000. And we know there are 10 pairs of tickets, so I want to divide that by 10. So let me save that. I'm going to refresh the page, change this to 40,000, and now update. So you can see that that works. The update probability is working, but for some reason that event isn't firing. Let's go back to look at this. Select changed. So let me try a different event. I think, unfortunately, I'm a little bit afraid I've come into a P5 bug here. Oh no. Yay, this is working now. So I don't know why the change. So there are two different event functions associated with when a DOM element's content changes. There's the changed function and there's the input function. The changed function only changes when triggers when you've completed your action. Like you've pressed enter or tab to leave that DOM element. The input event fires continuously anytime you're changing your typing. So I don't know why the changed one didn't work. I'll look into that later, but I kind of wanted the input one anyway. So what I now have is that you can see that as I change this number, 1,000, if I change this number to 1,000, I have a 1 in 100 chance of winning. Now, how do I change this number though? I want to also change that number there. So remember the first video I did, all of this math to figure out how do I have a 99% chance or a 1% chance of not winning the lottery all of those times is the equivalent of a 99% chance of winning at least once. And so the way that I solve that is log base 10 of 0.01 divided by the number of chances I have to win the lottery. This number, you go back and watch the first video where I explained this particular math. So what I need to do is go back in here and also update that. So the chances of me winning, the chances of me not winning the lottery just once are entrance. So I'm going to make this a variable. Total entrance equals this, entrance.html. And that way I need to use this variable over and over again. So I need to say total entrance minus 1 divided by total entrance, right? That's the chance of me not winning. To make this a little bit wider, that's the chance of me not winning one time, right? If there's 1,000 entrants to the lottery and I'm 1, I have a 999 out of 1,000 chance of not winning, or a 1 out of 1,000 chance of winning. So now I want to the number of times to play for 99 are log of 0.01, come back camera, divided by log base 10 of not winning. So, oh, this camera went off too. Oh boy, this video is a disaster. Log of I shouldn't be looking at the comments. People are like probably complaining there. Don't look at the comments of the live chat while I'm doing this. The log of 0.01 divided by the log of not winning. And I need to also say 1 minus that. No, that's right. No, I don't need to say that. I got confused for a second. Because 1 minus 0.99 is where I needed the 1 minus. Okay, so now I want to say select 99 HTML times to play. So if we go back here, and you can see here that if I change this to 40,000, cannot read HTML of null. I have a feeling that you can't have an ID start with a number. Was that line 30? Yeah, line 30. So I probably in HTML you can't have an ID. Oh, 99%. Maybe you can. I just had the wrong thing. 99%. Let's try this. Change this to 40,000. Right? And you can see here, there we go. Oh, my math is wrong. Because 50,000, 230,000. What did I get wrong? Okay, hold on, pause. This video has kind of been a disaster anyway. I can just pause it for a second. I'm going to go back at some point. What did I do wrong here? I'm losing my mind here building this little project. Total entrance minus 1. Oh, not total entrance. Probability. So I didn't need to make this a separate variable. I knew I made a mistake somewhere. So this is right. So now if I, and I should floor this also. So now if I change this to 40,000, I got to play 18,000, 20,000, 10,000, 60,000, 600,000, So you can see how this is working. And then just see, does the lottery actually work? Yeah. Because it's using that number probability. Okay, sorry, I got to figure out where I'm going to, maybe I should do, I kind of want to do this whole section again, and I would if it wasn't for the live stream, which is probably, people are saying hi to Hamilton. Why are you using, somebody asked, why are you using floor instead of int? Floor, that's a good question. I could just use int. Floor is a bit more native to JavaScript. Int is something that's part of P5 just because it was in processing to sort of keep some compatibility. But int isn't really necessarily the most legitimate way of doing this. I only have 15 minutes left before I kind of have to go. So I need to watch back what I just recorded there and pick up a point to go from again. So I think I want to try to go from, you guys can't see what I'm looking at, I apologize for that. What I want to do is go from, trying to look, okay, so I'm watching myself now and I'm about to, I wish I could hear myself, that would be helpful. I'm talking, I wave my arms around a lot, apparently. And goes forward 4 to 10 minutes. And I'm going to, so I'm going to go back to the part, I screwed up, I'm going to go back to the part. Am I here? I lost right. I'm going to go back to the part. Oh yeah, okay. I'm going to go back to the part where I'm going to do this again. So I need to look at the code for a second. Sorry, to look at something else. I'm going to go back to the part where I'm just looking in here. I don't have this. Just going to go back to this part. Great. So this is now where I was updating this. And there, okay. So I'm going to start from there, which was at 11 minutes and 14 seconds about. I need to write that down. 11:14. Try to remember that. And now I need to go back to the code and go back to here. Okay. And I'm going to cycle these cameras. I'm going to drink some water. Okay. Okay, so now I'm going to come back and try this part again. I guess maybe I'm going to take this away. Okay, here we go. Keep that there. Okay. So I'm going to hit record. I'm trying to figure out, I think there's a point where I went over here, and I'm going to do that. I don't know. Hold on. Shoot. Yeah, it's fine. I'll figure it out later. Technical mishap, weird edit. But where I'm back is looking at now applying this formula, which I covered in part 1, of how to actually compute the number of times you need to play to have a 99% chance of winning the lottery at least once, with log base 10 of 1% divided by log base 10 of the chance of not winning the lottery one single time. Okay, so if you want to remember that formula, go back to the first video. But for right now, I just need to find the place where to put that formula in to change that number, 23,000, right there. So if I go back to the code, we can see here that this is, if you recall, I just did this a moment ago. This is where I'm changing the probability number. And the other number I want to now do is, first of all, so what's the chance? I'm going to make a variable called not winning. What's the chance of me not winning the lottery just once, right? 4,999 divided by 5,000. Well, that number 5,000 is now something that's shifting. So what I want to say is probability minus 1 divided by probability. That's the chance of me not winning the lottery just once. So now the number of times is log of 0.01 divided by log of that not winning probability. And now that's the number that I need to update right here. That's the number 23,000 that I want to change. So if I do that, all I need to do is select, and the ID for that span was 99%, .html num. And I think it's probably worth also using floor here because I'm going to get like a long decimal number. So I'm going to put floor here to take off that decimal. And maybe also what I'll do is I'm going to put that approximately. It's not really that approximate anymore, but I'll keep that in there so the span always keeps the approximate symbol. So if I do this, you can see now 50,000 people are entering the lottery. I have a 1 in 5,000 chance of winning, and I must play 23,000 times to have a 99% chance of winning the lottery at least once. So let's change this to 20,000. Oh, that's well, the approximate was already in there. I don't know why I added that in the code. It was not part of the span in the first place. So let me do that again. I'm going to change this to 20,000. So you can see now I have a 1 in 2,000 chance of winning, and I have to play the lottery 9,208 times in order to have a 99% chance of winning at least once. So this is what I'm calling kind of a dynamic essay. I mean, there's no essay here, but as I change one value, other things update. I'm not going to go too much farther with this, but I am going to post this entire thing on GitHub, a link to it. I would love for people to add to this, send pull requests, add design elements. You know, it might be more interesting if you could hover over this and like slide your mouse back and forth to change the number, like almost as if it were a slider. This is not my original idea. There's lots of people creating work like this. You know, Brett Victor being one person to mention who's made a lot of these types of educational things online with lots of manipulable things. But let's just make sure, one thing I want to look at is make sure the lottery is still working itself. The other thing I should mention is look at this. If I say 0, I get a 1 in 0 chance of winning, and then I get not a number. If I start putting some letters there, I get 1 and not a number. So it also would make sense to have some kind of error checking, and also it'd be nice to format the numbers with commas. You guys submit pull requests to the GitHub repository that I'm going to post in a moment, and we'll see. Okay, so let's make the lottery now have 200 people winning each time. So you have a 1 in 20 chance, and I don't need the console anymore, so give ourselves some more room. 200 people are entering the lottery each night. That means you have a 1 in 200 chance of winning, and you have to play about 89 times to have a 99% chance of winning at least once. We won after 61 times. We won after 49 times. We won after 35 times. So you can see this idea works. And now I could change this to 2,000, and we could run it again, and it should take us longer to win. I would expect that by the time we get to 1,000, we're going to win 367 times. And now I'm going to say, let's just say 75,000 people are entering the Hamilton lottery. To have a 99% chance of winning the lottery at least one time, we're going to have to play about 34,000 times. So let's start winning, and let's hope that we're lucky. I didn't get it on the first try, unfortunately, which means I don't think I'm going to see Hamilton this evening. I'm going to let this run. I will leave you in suspense. Ask in the description of the video, in the comments, I will let you know how long it took for me to actually win that lottery. And look in the description for this video to the link to the GitHub repository and the website where you can add and contribute to this. Okay. So everyone who was watching this morning, I thank you for indulging me with this weird sort of project that I wanted to work on this morning. I'm going to, it's actually already, it's already online, but so I'm gonna, actually what I'm gonna do is, before I sign off, what time is it? 11:40, I have like 10 minutes. I'm gonna check my phone for a message. I'm walking over here, you guys can still hear me. I do have a text message. It's not the one, not important. So what I'm gonna do is, before I leave, I want to upload this to GitHub so that people could add to it if you want. So what I'm going to do is github.com Schiffman repositories. I actually was mucking around with this earlier, and what I'm going to do is get this, and I'm going to say in terminal. I'm doing this quickly, and then I will. Hopefully this will come. Am I logged in? Public key. So I need to shoot. Let's see if because I'm not logged into my usual user account, so this should work. And what I'm going to do is here, and I'm just going to replace it. I probably added some fancier stuff to it. Which one was I editing just now in Sublime? One. So I'm going to get this, and I'm going to put it in here. Whoops. Get these files. Hold on. Get these files, copy them over here. Apply to all, replace. And I'm going to go back to terminal. Whoops. Hamilton. And so I'm going to lottery code from video lesson. And let's see if it lets me push it. Great, ask user. Yay, okay, so now that's pushed. So the code should be here, right? So this is the GitHub repository, github.com/Schiffman/Hamilton Lottery Simulator. And you can actually then go to schiffman.github.io/Hamilton. It's GitHub Pages repository, lottery simulator. Let's see if that works. Yep. So what I've got to go, and I'm going to be out for a couple hours doing some other things I have to do today. But if anyone is interested in the idea of this, I would love for you to clone this repository. You might not know. I apologize if you're not used to sort of the GitHub and GitHub Pages thing. I am going to make a set of tutorials about that. But clone this repository, add stuff to the web page, change the design, make some pull requests. I'd like to write a bit more about how the math works on this page. I might embed the videos that I'm going to upload. I'd like to add more features to being able to play with it. I'd like to link to the actual lottery. I'd like to make this a much more thorough page with more content, and I would be glad for anybody to contribute to that. So I'll probably work on it more later. And I also have to edit these videos together because that was kind of yeah. So in some ways, I sort of almost want to re-record all of these, but that's not really my style, I guess. More info about the math would be great. Can you do a video about GitHub? 100%. I'm planning to do, I forgot to see, am I still going? You know what's interesting? I think P5 is set up to have the draw loop stop when you've moved to another tab, because why bother animating if it's not in focus? So let's just confirm, because I'm only at 6,000 times, which is crazy, because, right? What if I go to another tab? It was at 6,600. I'm talking. I mean, it should at least gotten to 7,000 by now. If I talk for a little bit longer, it'll probably get to 8,000. Remember, it was just at 6,600. I'm going to talk for a little bit more. See some of the questions. Yes, I'm definitely going to do videos about GitHub, more info about the math. I did a whole video about the math, but I don't know how good it was. Yeah, see, it's still at 6600. So I have a flaw, which is not really a flaw, but you have to actually have your tab open, which I guess I could probably change, or I could use set interval instead. So maybe I'll adjust all this stuff. It should do something much more exciting when you actually win. And let me see if there's any other comments. I have to go. Oh, the name I mentioned was Brett Victor. And you can look at like Brett Victor, maybe like Kill Math. He has a bunch of like online essays, I think, that if you like read stuff and you can like tweak stuff in it. He has a term for it, and I don't know, I'm kind of, my brain's a little bit melted. Make the sketch, enter the Hamilton lottery directly and automatically get a ticket every day. Well, the problem with that is it would be somewhat unethical. I think because technically the rules of the Hamilton lottery is only one entry per person. So you're right, it wouldn't be that much of a leap to do it, but you would also need to have infinite email addresses, and it would probably notice that you have the same name and birth date. Okay, everyone, I'm hoping to be back later this afternoon. I always say that, and I often am not. I might be making some more tomorrow. If not, I definitely will be recording videos next week. And next week, I'm committed to doing Git and GitHub tutorials. Actually, I might do the Node stuff next week and the Git and GitHub the week after, because I have something else next week that I'm doing that has to do with Node. So doing those videos might be more helpful. But in the next 2 weeks, I'm going to be doing videos, some more videos about Node and some videos about Git and GitHub. So those are coming. And I got to turn off the stream now, and I will see all of you later, I hope. Okay, goodbye.